Hello, and welcome to Advanced Geometry with Spline. I'm Charles Poe, and I'm a developer on the Discrete Computation team. I'm really excited to talk to you today about our Wolfram geometry computation and how it opened the door for you to create and analyze amazing geometric objects with Splines. So let's get started. Wolfram geometric computation is a core part of the Wolfram language and provides a comprehensive set of integrated tools and solutions for modeling, analyzing, visualizing, synthesizing geometry. In fact, you have several choices when it comes to which modeling approach you can use and best suited for you on your project. And that includes constructive solid geometry and implicit representation. For example, you can model geometric region in 2 and 3 dimensions using polygonal mesh or from building primitives such as disk, ball, toroids, and combine them, transform them to create new ones. You can also increase your workflow efficiency by importing geometric regions and by exporting your work in a wide range of 3D geometric and modeling formats, including STL, OBJ, and DIEs. We leverage our document-based notebook interface to handle this geometric region with insightful structure and realistic appearance. You can interact with 2D and 3D rendering of your model and style elements using different types of light, material, and cameras. With these high-quality graphics, you can visualize over geometric region and gain immediate insight about your data and functions. This is fully integrated in our rich collection of highly automated plots. For example, you can show temperature, stress, fluid flow, and computed property directly on your models. Now, behind the scene, Wolfram geometric computation is powered by an extensive collection of state-of-the-art geometric algorithms, including triangularizations, convex hull, and data structures. You can directly type into it to build your work, to analyze, and to understand spatial structure in various areas. Use the mesh processing pipeline to understand intricate geometric structure and property of your geometric data. It enables you to construct triangles and polygonal mesh of scan or tomographic input data, to remove topological or geometric error, to remesh and improve your mesh quality. These geometric regions are first-class citizens in the Wolfram language. They can be used as input and output, and they are deeply integrated in the rest of the language. You can solve optimization problem, algebraic equation, and partial differential equation with geometric constraint. In this example, we find the distance and the nearest point between 2 convex polyhedra by formulating the problem as a quadratic optimization problem, using the convex polyhedra directly as inputs. We may also bridge domain analyze geometry using graph, reconstruct geometry from image or computer maps. Now, to bring your idea to life in the real world, you can 3D print them. Wolfram geometric computation provides fully integrated capability to directly 3D print geometric models using either an online printing service or your own 3D printer. You can also create interactive simulation for games, AR and VR immersive experience. Publish your model directly to AR device and take advantage of the connection between the Wolfram language and game engine to programmatically control your creative and development process. As in programmatic CAD, 3D objects in Wolfram geometry can be designed We are using Spline to bring the design simplicity of the traditional CAD system to Wolfram geometry. So what's a spline? A spline is a piecewise polynomial curve or surface. Splines are popular because of the simplicity of the construction, the ease and accuracy of evaluation, and the capability to approximate complex shape through curve fitting and interactive curve design. Splines in the Wolfram geometry include a boundary representation where the region is represented by its boundary, a curve in 2D and a surface in 3D, or where the region is represented as disjoint union of sample cells, as in mesh regions. This spline-based region can be constructed in a variety of ways, including from point, extrusion, and Boolean operations. Spline-based region just work like any other region. They can be analyzed, used as input to solver, or as building block to construct more complex regions. Okay, I will go through a few set of questions. Before that, so let's just conclude the presentation by pointing out actually the future directions for geometry, at least in the next coming release. One of the main focus actually of the whole project is always to add more modeling, analysis, and computation, and definitely jump in verticals. So we did so with adding mesh regions. For the analyzing, we have a whole subsystem for mesh region, and one of the vertical of mesh region was 3D printing. So for the coming release, we are actually focusing, as you saw here, on splines, and we hope to have a whole subsystem for analyzing and computing on spline, but also have a vertical in terms of CAD connection to CAD system and interacting with CAD system with all that spline set of feature and functionality we are going to provide. So we hope in long term to actually be not per se compete with CAD system, because they are more in the interactive side of computer design, but also to have that programmatic side of CAD, as well as the unique capability in terms of computation on splines. But also we'll continue to kind of improve the usability of the functionality in geometry. We are going to add more auto visualization and improve the performance. And one example, when I actually say about talk about auto visualization, it's for example about Boolean regions. So when you build a Boolean region of, for example, a symmetric difference of two disks, in the current functionality or the current release, you get an evaluated object, which most of the people think, nothing actually happened, which is usually the case in the system when something comes back unevaluated. But in principle, this object you can actually compute on it, right? So what we hope is to actually add an auto visualization of the object, where you don't actually need to convert, wrap it around region or do anything else. The object will directly auto-visualize. And you'll get directly the perception that you can actually manipulate it. You can compute on it. You can compute the area and do any other type of computation on that object, right? As well as computing, integrals or plotting function on top of it, right? So that's kind of one side of the usability we are planning to add, obviously for transform region, Boolean region, transform region, inverse transform regions. But we'll also continue to improve the integration with the compiler, for example, and expose more data structure, which will be quite useful for people who actually want to work on the low-level side of geometry or do computational geometry. So that's kind of some of the set of feature we plan to add. Right? But also in terms of education, I'll kind of bring all that to you. We are improving our documentations, making them look much nicer, better integration with our graphics functionality, and there will be course and book on geometry, as we are doing also in other areas. So in short, that's kind of the big view of geometry and what we plan to do in the next feature. So I'm going to go and look at some of the questions here and try to answer them. Well, so first, the presentation should be available under the handout. I was able to share that. And so one question here is there a plan to support Bezier triangular mesh or more other spline, T-spline and U-splines? Well, at this time, we are just going with our B-splines and see how far it will bring us, but we are open to extend it, and if there is need, and feel free to kind of send us an example or use of those different type of spline, and we'll kind of consider them to add them and extend them. Another question, so when I open the notebook, only the slide show. There's no presentation control on the side? Oh, okay, so that's from Bruce Collection, the slide notebook. So I will look at the presentation notebook I share and try to fix that if there is any issues. Okay, I will wait a little bit more minutes here and see if there is any more question related to geometry. And as I pointed out in the earlier slides, we have office hour of geometry tomorrow at 1 to 2 p.m. So if you have any question or any issue with the current functionality or any suggestion of the future direction or what you'd like to see in our geometry functionality, please don't hesitate and come by and stop by and let us know. Okay, well, thank you for coming by, and I hope you have a great rest of your conference. Thank you.